Started. So yesterday we've learned how to solve. Yesterday we have learned how to solve quadratic equation over complex numbers. Today we're learning how to solve polynomial equations over the complex numbers. So for the equations in order more than 2. For example, cubic. And before we will do the actual solving those equations, few things that we need to look into. And first of all, if we have some polynomial equation of z a and z in the power of n plus a n minus 1, z n minus 1 plus plus a 0 equals 0. There is a, as you remember from methods, factor theorem. If we have that z equal, let's say z1 is the solution. If z minus z1 is a factor, that means when you substitute z1, this is p of z, then p of z1 will be equal 0. Same factor theorem as we were doing in methods for real numbers. If z minus z1 is a factor of this polynomial, then when you substitute z1 instead of z, it will be equal 0. That's one thing. Second thing is so-called fundamental theorem of algebra, which tells us that if we have the polynomial, the equation with order of n, it can be factorized into the n linear vectors. So it can be factorized into z minus z1 times z minus z2 times z minus zn. So this equation will have n solutions. It could be that some of those solutions are the same, that factor is repeated. Like we had, for example, solving cubic equations in methods in the real numbers, we could get that, let's say, x minus 2 times x plus 1 squared. We factorize cubic. So this is actually 3 solutions. Because x equals -1, just had to say multiplicity of 2 is repeated twice. Because if you expand it, we have 3 factors: x minus 2, x plus 1, x plus 1. So we have 3 factors. Just 2 of them are the same. So when we say that equation of the power of n will have n solutions, that means some of them are repeated, some are the same. But overall, we can factorize it to n factors. This is a fundamental theorem of algebra. And one more theorem, conjugate root theorem, which we will derive later on, not now, but when we will be learning proofs, we will prove this theorem. So now we not proving it, but just use it. If we have polynomial equation of like this, and all coefficients are real numbers, because coefficients of the equation, coefficients can be complex numbers. They're not necessarily real numbers. But if they are real numbers, the solutions come in conjugate pairs. So if all coefficients of A are real numbers, then if A plus bi is a solution, then a minus bi will be a solution as well. This is a theorem which can be proved, which I just said. We will prove it a little bit later on, because to prove this theorem we need to use so-called mathematical induction, which we will learn later on, which by the way will be quite important part for the Unit 3 for mathematics. Out of all proofs, mathematical induction will be the most important. So, based on these three, factor theorem, fundamental theorem of algebra, and conjugate root theorem, we can solve cubic polynomial equations. So let's consider some examples. Let's say first example. So, let's consider the next example. First, show that, do it differently. Solve the equation z cubed plus 2z squared minus 3z minus 10 equals 0. Solve such cubic equation. What is the first step? How you solve in cubic equation? Why?
Yeah, 1 plus 2. No.
Does 1 work?
2.
1 does not work.
No, but it's 9.
Negative 1.
12 minus 16.
So, first step, we try to find, by trial and error, it's not from the booklet. It's not from the booklet. So, first, by trial and error, we find in one solution. And we can find that z equals 2 will work. So, z minus 2 is a factor. So, what we should do now?
Division.
Polynomial division.
You gotta be kidding.
So, we divided z cubed
Like I'm just synthetic division.
plus 2z squared minus 3z minus 10. You can do by creating coefficients, you can do synthetic. There are few different methods how you can find the result of the division. Let's do polynomial division. Z cubed over z, we have z squared minus z cubed minus 2z squared. So we have 4z squared minus 3z plus 4z.
Minus 10.
So we have minus 4z, z minus 2, and this we have minus 4z squared minus 8z. We have 5z minus 10. So we have 5 plus 5, and obviously minus 5z minus 10 equals 0. So we have z squared plus 4z plus 5. Now, so this factorizes to z minus 2 times z plus z squared plus 4z plus 5 equals 0, and z squared plus 4z plus 5 equals 0. In real numbers it doesn't have any solutions, but in complex numbers it have two solutions, z equal minus 4 plus minus square root of 16 minus 20 over 2, so equal minus 4 plus minus 2I over 2. So we have two more solutions that equal minus 2 plus I or minus 2 minus I.
What about the original one? Z equals
And
2.
2. And Z.
So we have Z equals 2, one solution, and then we get two more, minus 2 plus I, minus 2 minus I. So in real numbers, it could be that cubic equation have only one solution. By the way, cubic always have at least one solution. There is no case that cubic doesn't have any solution. But in complex number, if it's cubic, it must have three solutions. And they are going in conjugate pairs. Minus 2 plus I, minus 2 minus I are conjugate. And what about 2? What about 2? Because 2 is 2 plus 0I. So it is conjugate to itself. Number 2 is 2 plus 0I, the same as 2 minus 0I.
Rotate 0 degrees.
Yeah. Makes sense how we solve this cubic equation over the complex numbers. If it's cubic, it must be 3. It could be that 2 coincide, could be, but it has to be 3 solutions. Make sense? Yes. Now, another example. We have equation, next equation, z cube, z cube minus 9z squared plus 31z minus 39 equals 0. And it is given that one of the solutions is z equal 3 minus 2I. Find all solutions.
Is this an example of error system?
It's from the textbook, which you still need to do.
Perfect.
So,
If you had to prioritize one, would you prioritize the textbook or the booklet?
And you can't say both. Yeah, you can't say both.
okay, I will say the order, the best order in which you do booklet questions not from the past exams, then you do textbook, and then you do past unit 3-4 exam questions after that. Because they are hardest questions. So, if 3 minus 2I is a solution, what other solution we should have?
3 plus 2I.
So we have z equal 3 plus 2I is a solution. So let's multiply z minus 3 plus 2I, z minus z1, this is z2, times z minus 3 minus 2I. Let's multiply these two factors. Because if this is a solution, then z minus z1 is a factor, z minus z2 is a factor. So let's multiply. And what will be the best way to multiply? Because we have 3 and 3, what will be the best way?
You just
Separate.
We do add bracket
You have a
here.
difference of perfect squares. No?
And when we do like this, it will become difference of 2 squares. So we have, will be equal z minus 3 squared minus 4I squared. Can you see that? When we combine this z minus 3, then plus minus will be minus 4I squared, which becomes plus 4. And we expand this, we get z squared minus 6z plus 9 minus 4, z squared minus 6z plus 5. What should be next step to find the last solution?
Quadratic form.
No, you divide that by
minus 5 minus
We divide this by this. We divide cubic. This quadratic is a product of two factors.
It's just 3.
Yeah, -3, -2.
Oh, whoa.
Yeah, just three.
Okay. 3, let's check. 27 minus 27 plus 31 times 3, 39 minus 39. Yes, it works. Sorry, no, 31 times 3 is not 31, 39. No, 3 doesn't work. 3 doesn't work. Let's divide it. Let's divide z cubed minus 9z squared plus 31z minus 39 divide by z squared minus 6z plus 5 z cubed on z
Wait,
squared.
this makes plus 4. There, you did mine.
Plus 4, yes, so plus 13. Thank you.
I think it is.
It's not sweet, man.
The plus 13, it probably will be negative 3. So z cubed over z squared is z times z minus z cubed minus 6z squared plus 13z. We get minus, well, we get 3z squared, negative 3z squared. 31 minus 13 will be positive 14. Z minus 39. No, is it not 14? 18. 18 plus 18. Yep, and so Z, we have Z minus 3.
That's it.
Yeah, that's it.
Yeah, that's enough.
That's it. So it's 3. The answer is 3. Again, 27. My bad, 20. 20. Yeah, 3. You were correct. 27 minus 81. That's why we plus 93 minus 39 equals 0. So the third solution is equals 3. Yes. No. Okay. So that's how we solving polynomial equations over complex numbers. Now just need to practice on that. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas, etc. Support Ukraine and Israel.